It's interesting to note that no two human beings have the same fingerprints. Also, scientists say that no two grains of sand or snowflakes are identical. This may be hard to accept, but if you study grains of sand or snowflakes with a precise device, you'll see subtle differences. These differences illustrate the concept of variation. Variation is a structural or functional difference between closely related items. Before the quality movement, sellers and buyers learned to accept differences in what they made or what they bought. It's close enough, or that's good enough, became common phrases. People would find a way to accept an item either by adding other things to the process, like filling in the gap with some glue, or by modifying a part that had variation, making it smaller by sanding the edges. As time went by and variation became too costly, companies brought on inspectors to look for differences and reject non-conforming products. Unfortunately, their methods to determine what was suitable were often subjective. Sometimes they would reject usable products and accept defective ones. In many cases, technical personnel didn't have the knowledge to design processes and inspection operations to meet customer requirements. The goalpost method of inspection was, and still is to a large extent, the primary way to determine quality. If you or a family member plays soccer, you're familiar with this example with goalpost. We can relate them to business too. In soccer, you score a goal whenever the ball crosses a line on the ground between two goalposts. It doesn't matter if the ball is in the center, lower left, or upper right section of the goal. Let's relate the goalpost analogy to quality. Suppose that a company buys part D that should be between 2.9 and 3.1 inches. This means that they should reject a part that is 2.88, less than 2.9, or 3.12 inches, greater than 3.1. Consider this question. Will a 2.92 inch part function better than a 3.09 inch part? Both parts are at the extreme areas of the acceptance range. And what happens if the best that a supplier can do is supply part Ds that are between 2.8 and 2.85 inches? According to the goalpost, these are non-conforming parts. But how far away are they from being acceptable parts at 2.9 inches? Companies frequently struggle with these questions. They usually ask a group of experts called a Material Review Board, MRB, to evaluate the usability of these borderline parts. The MRB recommends 3 possible actions: use the part on a limited basis, reject the parts, or accept them and change the acceptance criteria. Regrettably, they often make their decision with incomplete information and are under pressure from production to release the parts. There must be a better way to determine conformance to requirements. Fortunately, there is. Let's look at another example that gives us a better approach than the goalpost method. It's called the Taguchi loss function. The Taguchi loss function provides an alternative to relying on the goalpost method and relying on specifications. Here's an example to illustrate how it works. I recently taught a course in a hot classroom. The following week, I taught the same course in the same classroom, which was now cold. I noticed that my students' readiness to learn was not the highest. After I completed these 2 courses, I realized that I could use the Taguchi loss function to measure variation and meet my student requirements. At a target temperature, probably 70 degrees, most students are content and are ready to learn. As the temperature increases or decreases, more students become less ready to learn. They begin to fan themselves or squirm in their chairs when it's hot, or begin to shiver or look for a jacket when it's cold. Here's what the Taguchi loss function is all about. When the upside down bell-shaped curve is at its target, the lowest point, the greatest number of people are satisfied. As variation rises and the curve increases both to the right and to the left, companies realize higher cost because what they produce doesn't conform to what they expect. When a process exceeds upper and lower control tolerances, the UCT and the LCT, customers won't accept products. This creates rejects that need to be reworked or scrapped. Reducing variation is desirable, but first, it needs to be measured. In statistics, variation is measured by the dispersion of data, which refers to the distance of events or conditions, temperatures or dimensions of parts, from an ideal spot, which is the target. Standard deviation, SD, is the best way to measure variation. SD measures the distance from a group of observations from a population's mean or the average. Since this is a mouthful, let's look at an example. Suppose that I coach two men's soccer teams, each comprised of 11 players. I weigh the players and find that their average weight is 160 pounds. I calculate SD for the two teams and find that for the first team it's 20 and the second is 32. Since my second team has a higher SD, there is more variability of players' weights. This means my second team has more heavy and light players. To find SD, you take the square root of the variance. If you want to know more about it, look at any YouTube video or Google this topic. Employees usually only produce a small amount of variation, called special cause variation. An example is a defective product that's made because an employee purposely did not follow instructions. On the other hand, management produces a great deal of common cause variation, also known as system or normal variation. An example of this type of variation is management retaining an old piece of equipment that produces non-conforming parts. To conclude our discussion about variation, it's vital that you reduce it. You can never eliminate variation, but you can decrease it so you satisfy your customers, help your company make profits, and reduce your dependency on inspection at your suppliers' locations or your own. Before we wrap things up, let's turn our attention to a related concept to variation. To help you understand the function and intent of statistical process control, abbreviated as SPC, let's first look at each word. Statistical involves the use of numbers and measures. Process is a series of actions, and control produces desirable and predictable results. If we slightly arrange these phrases, SPC is the use of numbers and measures to cause a series of actions that will produce desirable and predictable results. Prevention requires a deep knowledge of processes. It's important that you start out by clearly identifying inputs, human resources, materials, money, equipment, and information. Then you need to understand how each input relates to one another and also what takes place when each input separately and together is processed. I realize this is a lot to know. It's no wonder that most firms use detection instead of prevention. It's a lot easier. There are three different possible conditions or states related to processes. First is the brink of chaos or chaos. As it sounds, companies in this condition produce a high degree of non-conforming product where variation is unknown and customers are not satisfied. Next, we have the threshold state. Here firms produce some non-conforming product, but the process is still predictable. Most organizations are in this state. The best is the ideal state. This means that a firm produces 100% conforming products where variation is small and the process is predictable and acceptable. To move from the brink of chaos or threshold states to an ideal state, firms must increase process understanding, improve current processes to reduce existing costs and enhance customer satisfaction, and develop innovative and low-cost products and services. Firms can effectively apply SPC and maintain an ideal state by following these principles. First is to make SPC a company-wide effort. Top management must support SPC and encourage compliance by the entire organization. Next, use data for decision-making. You need to satisfy customer requirements, both external and internal, on a rational basis. Avoid making decisions on an emotional basis. When we implemented SPC at my first company, we wore buttons that stated, "Show me your data," and without data, you're just another person with an opinion. Next is to proceed systematically. You need to follow organized, well-defined, and well-documented policies and procedures. Make every effort to complete tasks in a logical and standardized way. Then you need to use measurements effectively. When you collect data, compare results to targets and take timely corrective action. Then comes achieving statistical control. A product in statistical control means that all special causes of variation are identified and eliminated. Processes are predictable because all that remains is common cause variation. It's important for you to know that just because a process is predictable, it doesn't necessarily meet customer requirements. Next is to reduce common cause variation. As the Taguchi loss function proposes, it's essential to reduce common cause variation so that processes will produce uniform output that satisfies customers and makes profits. Finally, everything should make business sense, but many organizations never improve their processes or develop exceptional new products. Why is this? I find that many companies are impatient. Using a baseball analogy, they want to hit a home run their first time at bat. Hitting a home run requires a great deal of practice. When companies begin with SPC, it's better to take small steps, hit singles, because they will help you cross home plate in less time and with a smaller amount of stress. Other reasons why organizations struggle with SPC is because they lack management support, they don't maintain a quality mindset, or they don't know which improvement methods to use. Once firms overcome these obstacles and are ready to improve processes, their next question should be, which process should we start with? The following questions should guide their efforts in providing an answer to this question. What do we want to achieve? This question can be answered by reflecting on quality objectives. Who are our stakeholders? This question will focus attention on external and internal customers. What is our current process and how is it performing? This question will force an assessment of existing practices and determine current levels of satisfaction. Where are the opportunities for improvement? This question can help determine existing gaps between desired and actual results. What are the barriers for improvement? This question identifies obstacles, many of them probably having to do with common cause variation. And finally, how can we improve? This question should result in several projects that firm should implement using a pilot or on a small scale basis. This concludes our lecture for the day. I hope you enjoyed it and learned a lot.